Hey, what's up? It's your old pal, Mr. Cook, and we are working on the Unit 6 B extra review. So this stuff is basically just like graphing. There's no real, solving with right triangles. There's no word problems. It's just straight up definitions and properties and things like that. So let's go ahead and work through it and talk about the definitions as we get to them. So given that some angle is equal to negative 23 pi over 4, remember that 23 pi over 4 is just the measurement of some angle. And remember that the angles we can either express in terms of degrees or radians. They mean the same thing. It's kind of like meters and feet and all that stuff. It's just a unit of measure for an angle. And there's a way to kind of go from degree to radian also, and that's the following. If you have a degree value, if you multiply it times pi and divide by 180, that's going to be a radian value. And if you have radians, you want to turn them into degrees, you multiply it by 180 and divide out pi. That'll give you some degree value. So if you don't understand what negative 23 pi over 2 represents, maybe degrees might help you out a little bit better. So if I needed to sketch this angle, maybe it'd be better to draw it up as, a degree measurement. So let's just convert it to a degree. So to convert from a radian to a degree, we need to multiply by 180 and divide by pi. So the pi's cancel out, and we get the following degree measurement. Let's see what that is. Negative 23 times 180 divided by 4. So it's negative 1,035 degrees. So maybe that makes a little bit more sense to you. I don't know. I can kind of look at them either way, and that's kind of the point of this whole entire chapter. We're supposed to get you guys used to using radians or degrees interchangeably. If you struggle with that, maybe converting to degrees can help you out a little bit more. But either way you look at it, this angle or this angle is greater than the maximum amount that we have for just one revolution of a circle. So like, for example, this negative 1,035 degrees is more than 360 degrees. So if I start to graph this out, it's more than a full circle's length for an angle measurement. So that's kind of a little bit weird. So how many circles does this go through? So for that, what we want to do is keep adding 360 degrees to see how many. That's one full rotation, and then add on another 360. That's another full rotation. So that means that if I'm going in the negative direction, so starting from standard position right here, if I go in the negative direction, that's clockwise. I've already gone through 2 full rotations. That's those 2 360s that I added on there. And I need to go another 315 degrees. So that's 90, 180, 270, and then another 45 degrees would put me right at negative 315. So this angle measurement that I just drew, going through 1, 2, and some change of a revolution, is that negative 1,035 degrees, or negative 23 pi over 4. Now, you can express that same concept with radians. You just need to know that negative 23 over 4 is this decimal value. It's 5.75 pi's, basically, pi radians. So 1 pi represents 180 degrees, or half of a circle. So if I have 5.75 half circles, that puts me at 1, 2, 3, 4, 5, and then 0.75 of a half circle, so another 3/4 of the way through there. So that still gives me the same exact angle measurement. Either way you look at it, this is your angle that you draw out. It's important to put down the arrow that we have at the very end there, right here, because that shows us that we've gone in this direction rather than the positive direction, which would be counterclockwise. Okay, so that's drawing it out. Now we're going to do a positive and a negative coterminal angle. And again, you can do it from either the degree perspective or the radian perspective. I'm going to put both of them up there, but just to let you know, as I get further down here, I'm just going to stick primarily with radians. So if you can't catch on with radians, just make sure that you remember that you can convert from radians to degrees anytime that you want. Okay, so with coterminal angles are angles that are found with the same starting position and the same terminal side, this little side that we get at the very end of the angle. So if I want to positive one of these, all I have to do is start at that negative 23 pi over 4 and keep adding on full circles until I get to a positive angle. So full circles for radians are 2 pi. So if I just take negative 23 over 4 and I add on 2 pi's, so 2 of them, then it'd still have a negative number. So since I need a positive coterminal angle, I need to add on 2 more and 2 more until I finally get a fraction that I can use, 0.25, which is 1/4. So one positive coterminal angle, which essentially is the same angle measurement, would be 1/4 of a pi, or pi over 4. And you can see why that's the case. If I were to graph a positive angle here, if I just went this direction, pi/4 would put me directly at this position right over here, halfway between 0 and pi over 2. So that gives me a positive coterminal angle. Now let's find another negative coterminal angle. So the neat thing is that I can just take this amount, negative 23 pi over 4, and subtract another 2 pi if I wanted to. Negative 23 over 4 minus 2 pi minus a full circle. That gives me negative 7.75. So that'd be, let's see here, 28, 29, 30, 31. Right, so that'd be negative 31 pi over 4. That'd be a negative coterminal angle. And this is kind of in a unique situation where I can add on 2 pi and still get another coterminal angle, like negative 15 pi over 4, because that's if I added on 2 pi on that, that's what I would get. All of these are negative coterminal angles. I'd only need to pick out one of them, and that's it. So that's using this in terms of radians. Let's go ahead and do it in terms of degrees as well. So with degrees, you know, this is the same thing as negative 1,035 degrees. That's what we converted that to as a degree. And, you know, going up one full circle or down one full circle is by adding on 360 or subtracting 360. So I can take that angle measurement, negative 1,035, and add on 360 until I get a positive angle measurement. See? And I get, oops, there's where was that? Negative 315, yeah. And then plus 360. So that would give me exactly 45 degrees. So 45 degrees would be my very first positive coterminal angle. And that would be a coterminal angle with negative 1,035 degrees, this angle measurement. See, 45 degrees right there. All right, now let's find another negative coterminal angle. So if I just take that negative 1,035 and I add it on 360, that would give me negative 675 degrees. There's a negative coterminal angle. Alternatively, I can subtract 360 from here and get another one. So negative 1,035 minus 360, that would give me another negative coterminal angle. There are literally like infinitely many negative and positive coterminal angles from here. You just got to find another one that's, you know, negative or positive. That's it. That's what we're asking to do. I took way too long describing all this stuff, but this kind of sets the stage for the rest of the problems so they can get much easier. Like, for example, find a complement and a supplement for this angle measurement right here. Complement means that the two angles add up to 90 degrees, or pi halves. So all I'd have to do is just take pi halves and subtract away 2 pi over 7. Now, if you are like me, you hate working with fractions. Actually, secret, I actually like working with fractions. I don't mind it at all. But you know, just the role that I'm playing right now, I hate using fractions. So what I'm going to do is take the fractions out of the equation and only subtract the fractions themselves using my calculator, and then adding the pi on a little bit later. So if I take pi halves and subtract away 2 pi sevenths, then that's the same as taking 1/2 and subtracting away 2 sevenths, so 2 over 7. So that gives me some decimal answer. I don't know what that is, so I'm going to turn it into a fraction. So you just go to second, turn to a fraction, and you have a different one on your graphing calculator, but you know where it is. It's in the math button that you have on the left-hand side of your graphing calculator. But if I just change it into a fraction, it's 3/14. So my complement to this is going to be 3 pi over 14. You just take the pi's out of the equation and then just subtract them. 1/2 minus 2 sevenths equals 3/14. So pi halves minus 2 pi sevenths equals 3 pi over 14. You can do the same thing for the supplement. The supplement it's you know, what you need to get it equal to 180 degrees. So I would take this plus the supplement, and that would give me 180 degrees, or pi. So what I can do is I can just take pi and subtract away 2 pi over 7, and that'll give me my you know, angle measurement in radians for the supplement. And I can do this one real quick because that's just 7 pi over 7. So 7 minus 2 is 5, so it'd be 5 pi over 7. And, you know, I'll show you how to do that. So 1 pi, 1 minus 2 sevenths pi, so 2 sevenths. And then convert it into a fraction. See, 5 sevenths, 5 pi sevenths. And those are your two answers. This is the complement. This is the supplement. Okay, and then for the last couple parts of this video, I'll just do the convert to radians, convert to degrees. So I've got 115 degrees, and I need to convert it to radians, so I use my little formula up here. I take 115, multiply it times pi, and divide it by 180 degrees. The degrees cancel out, and that leaves me just in terms of radians. So this is just a regular old little fraction, 115 and 180. Let's see what that reduces down to. 115 divided by 180, and then convert it into a fraction. So 23 out of 36. So it looks like they're only divisible by 5. So 23 pi over 36. And there's my reduced radian angle measurement. All right, now let's go ahead and convert from degrees to radians. So that's when I use the other part, converting from radians to degrees. So I've got 11 pi over 9, and I multiply that by 180, divide by pi. So the pi in the top cancel with the pi in the bottom. And then now I'm no longer in terms of radians, it's only in terms of degrees. So now I just go ahead and multiply all this stuff out. So let's see, 11 times 180 divided by 9. And I get 220, so that's equal to 220 degrees. So there's my answer for that one. All right, so that's the first 4 problems. I took a long time explaining all of this stuff, but hopefully that'll pay dividends a little bit later on when I'm just going to be using radian values pretty much the whole way through. So that's it for this video. On to the next one.